Okay, we will continue with part 2 of the notes. So now we're going to be taking a look at some of the finer details of these graphs. This top part here, you guys could do all this in your calculator. So there's really no mystery behind it. But this part right here with the domain, range, x-intercept, y-intercept, asymptotes, these are the main things that we got to make sure we are solid on in order to answer questions, especially questions dealing with logarithms, which we're going to learn are the inverses of these exponential functions. So for all exponential functions, the domain is always going to be the same. It's going to be all real numbers, or negative infinity to infinity, negative infinity to infinity, and negative infinity to infinity. Now the range is going to depend on the asymptote. And so the range is closely related to the asymptote. And the asymptote, hopefully as you guys remember, is this imaginary line that the graph approaches but never touches. And the reason why it's related to our range is because once we figure out what our asymptote is, then our range is going to be the values either above that or below that. And so happens for all three of these that the range is going to be the same because the asymptote for all three of these is this line right here, y equals 0. And so what that's telling us is that these graphs are going to get really, really close to the x-axis, but never actually go below them. And in fact, if you think about what negative numbers do when they're exponents, is they don't make things negative, they make them fractions or reciprocals. So our range here is going to be y is greater than 0, or if you were writing an interval notation, from 0 to infinity. And that's going to be the same for all of these. So now, if we know that the asymptote is y equals 0 and the graph will never actually touch the x-axis, then for our x-intercepts, it's going to be none. Now our y-intercept, of course, I don't need to remind you guys are the experts on this, we know that the y-intercept is where it crosses the y-axis. But also, if you're ever in a jam, know that the y-intercept is also, you can find it just by saying whenever x is equal to 0. And in this case, if we look at our table of values here, our y-intercept is going to be, for all of these, the same. 0, 1, 0, 1, 0, 1. All right, now, this is college algebra. This is not regular algebra. This is not advanced algebra. So we are going to be looking at more complex graphs. And for all of these, they all deal with the reflections and the shifts and the translations that we've talked about earlier. So like here, we have a reflection. Okay, here is another reflection. Here is another kind of reflection we'll talk about. Down here, we have a shift. Here's another shift with a reflection. And here is a shift and a vertical stretch. So the stuff that you maybe were hoping that you could get rid of and never have to deal with again, no way. We are going back to it. We're going to be focusing on it, and we're working on this, okay? So if this looks very intimidating to you, especially because I'm not with you guys or you can't get help during seminar, don't worry. You could put all this stuff in your graphic calculator. But make sure, though, that, again, you use your prior knowledge of shifts and translations and reflections to help answer these questions down here. Domain and range, x-intercepts, y-intercepts, all that good stuff. So, basically, you use your graphic calculator and get a feel for what this graph looks like. So if I'm going to get a table of values here for this first one, x, y, I know that it would be -1 and -1/2, 0, -1, and 1, -2. That, you can kind of do without a calculator. So just by sketching these, so -1, -1/2, 0, -1, and 1, -2, we know that this graph is going to look something like this. And we also know that there is our asymptote right here, because as you see, the graph approaches the x-axis but never actually touches the x-axis. So to answer these questions, actually all of them are going to have the same domain, but now the range, instead of being from 0 to infinity, is going to be from negative infinity to 0. And the reason why there is a parenthesis here is because of the asymptote. Remember, it's touching it but never actually, or approaching it but never actually touching it. The asymptote then would be y equals 0. The y-intercept is, of course, whenever x equals 0, so that's 0, -1. And the x-intercept, because that's where the asymptote at is none. Over here, another graph, table of values. So, just 3, 4, 5 points, perfect. Get a feel for what this graph looks like. So we have -1, 5.4, 0, 2, and 1.74. And we know that there's actually two things going on. We have a vertical stretch, and we have a reflection about the y-axis. So normally, if you guys remember, these kind of graphs normally look like this, and they all kind of all do. But when you have these applied to it, the graphs are going to look a little different. So quickly, I'm getting that 12-minute mark for YouTube here. So -1 and 5.4, 5, 0, 2. There's where you see that stretch, and 1 and 0.74. And again, here's a rough sketch of what the graph looks like. And we see it looks different. Like this is the mother function that we call it, and these are all going to be a little bit different from what the mother function looks like here. And now to answer these questions, this will be the same for all of them. The range here, this time the asymptote is at y equals 0, so it goes from 0 to infinity. The x-intercept again is a none, and the y-intercept is where x equals 0, so that's 0, 2. And then last one for these kind of problems, this, you could, if you want to think about it, is actually the same as saying y equals 2 to the negative x. So you can look at this as a reflection over the y-axis as well. In fact, it's just the opposite of this over here. So this one is going to look similar to the one on top, except reflected over the y-axis. So again, x, y. We have -1, 2, 0, 1, and 1, 1/2. -1, 2, 0, 1, 1, 1/2. We know eventually it's going to go up like that. And our domain is, again, the same for all of these. All these will have the same domain, 0 to infinity, x-intercept none, y-intercept 0, 1, and my asymptote is y equals 0. Now these ones down here, they require a little bit more. We have two things going on here, and if you think about, you play this game, like, okay, pause it and guess what Mr. Bass is going to say next. So if you pause it, and here's what I'm going to say next, is that this +1 is going to be a shift left 1. This -2 is going to be down 2. Now, that's if you're going to be looking at the original graph of y equals 2 to the x, and you could shift it from there. Of course, I'm okay with you guys just using a table on your calculator. So, I'm not going to expect you guys to not use your calculators on this. I want you to use your calculators. So again, -1, -1, 0, 0, 1, 2. We've talked about how you could just move the asymptote, and that will help with your, to see the shift better. So -1, -1, 0, 0, and 1, 2. And if you just use these 3 points, you might be tempted to say like, okay, well, this thing's going to go down or all the way down. But this minus 2 plays a huge role here. This minus 2 is your shift down 2, and that tells us that our asymptote has also been shifted down 2. So my asymptote is y equals negative 2. And something that's new with this kind of graph as compared to the previous graphs is there will be an x-intercept. Okay, and the x-intercept is 0, 0. We got lucky because we just got on the table. Sometimes you'll have to do a little bit of work to find that x-intercept. And my range is from negative 2 to infinity. Over here, remember our little trick when you have these kind of problems is this negative on the inside with the x. You got to factor a little bit. So this is really x minus 2 with a negative on the outside. So this is telling me that I'm really going to be shifting everything to the right 2 and a reflection over the y-axis. Now, again, use your calculators. Okay, I'm totally fine with you guys. Not this is great for understanding, but make sure that you use your calculators to verify your work. So negative 127, 0, 9, and 1, 3. A negative 127, we're not going to graph that, but you just, it's just way up here. 0, 9, again, way up here, I guess. And 1, 3 is right here. Whoop. And this asymptote is at 0, so, it's going to look something like this. You guys will draw it way better than I do. And our domain, again, is negative infinity to infinity, and so it is going to be for all of these. Our range is from 0 to infinity. And again, notice this is a minus 2 here. There's obviously there's a shift in our asymptote. We don't have that out here, so we know our range is still going to be the same. Our asymptote is going to be the same, and our y-intercept is going to be 0, 9, because we got that from the table, and our x-intercept is none. Lastly, we got two things. We have a shift up, and we have a vertical stretch. So you guys can play that game and see if it matches what you think it's going to be. So again, negative 1 and 1.67, 0, 3, and 1, 7. So negative 1, 1.67, 0, 3, and 1, 7. And this is our new asymptote. So our domain is from negative infinity to infinity. Our range is from 1 to infinity, because our asymptote is y equals 1. Our y-intercept is 0, 3, and our x-intercept is, again, none. Okay, I'm going to stop right here. Hopefully we get all this, and then we'll go to the last part.